Hello and welcome to my channel. My name's James and I hope to upload videos about electrical engineering and some other STEM subjects as well. Initially, I hope to add videos based on some of the questions that I get asked from time to time. If you find this video helpful, please subscribe for updates on future videos. You can also follow me on Twitter and you can find the link to my Twitter page here on my YouTube channel. So the question in this video is, can you use the armour of an SWA cable as the CPC? And the answer is yes. The wiring regulations includes a list of types of protective conductor, and it is possible to use the armour of the SWA cable. However, it is necessary to ensure that the electrical continuity is assured and that the cross-sectional area or CSA of the armour is sufficient to comply with the adiabatic equation, and that's what I'm going to be talking about in this video. There are some sizes of SWA cable that would not comply with the adiabatic equation and would not be possible to use as a CPC. So we first need to carry out the equation in table 54.7 of BS 7671 to ensure compliance. The next question is, how do we find the actual size of the steel wire armour? Well, this can be found in the manufacturer's information, which is usually available on their website. There is also a table in the IET Guidance Note 1 which provides sizes of CSA of the armour for various sizes of SWA cable. So for example, the CSA of the steel wire armour for a 2.5mm 2-core SWA cable is as much as 17mm according to manufacturer's information. So the CSA of the armour is much larger than that of the line conductor, but it is important to carry out the equation bearing in mind that the steel wire armour is a different material to the line conductor. So, is the size of the armour sufficient? To verify that the size of the armour is sufficient to use as a CPC, we need to make sure that it complies with the adiabatic equation. Table 54.7 in BS 7671 describes the equation to be carried out when the CPC is a different material to the line conductor, and I've just broken down some of the examples here. So the first one is where the line conductor S is less than 16mm, the equation is K1 divided by K2 multiplied by S. So K1 is the K value for the line conductor. K2 is the K value for the CPC, so in this case the armour of the SWA cable, and S is the size of the line conductor. Then where the line conductor S is between 16mm and 35mm, so for example a 25mm cable, the K1 divided by K2 and then multiplied by 16. And then lastly, where the line conductor is greater than 35mm, the equation becomes K1 divided by K2 multiplied by S divided by 2. So in other words, multiplied by half of the size of the line conductor. And so I've given an example here. So in the case of the 2-core 2.5 SWA I mentioned earlier, the calculation will be carried out this way. The K1 from table 43.1 is 115, and the K2 from table 54.4 is 51. So I've just shown the worked example below. K1 divided by K2 multiplied by S becomes 115 divided by 51 multiplied by 2.5, which gives us 5.63mm. So the minimum size of CPC is therefore 5.63mm. Therefore, the CPC of 17mm is more than adequate for that. So the next question is, which operating temperature shall we use for the SWA cable? Now, you will notice that there are values for both 70 degrees and 90 degrees in BS 7671. However, SWA cable is usually rated at 90 degrees. So you may be wondering why I have used the values for 70 degrees in the example. The answer is that it is possible to use the values for 90 degrees. However, if you do, it is necessary to ensure that the equipment that the circuit is supplying is also rated at 90 degrees. And it is also necessary to ensure that the cable won't be grouped with any cables that are rated at less than 90 degrees. If it is not possible to ensure that, you can still use the 90 degree cable, of course, but it is necessary to calculate the size of the cable by using the values for cables operating at 70 degrees. This will mean that a slightly larger cable is selected, and this is because a cable operating at 70 degrees can carry less current than a cable operating at 90 degrees. Thank you for watching my video. I hope you found this useful. If so, please look out for my next video, which will be on how to carry out the adiabatic equation for short circuit and fault current.